Independent t-test is used to compare groups of participants that are not related in any way. The groups are independent from one another, so participants in one group have absolutely no relationship to the participants in the second group. Different entities have been tested in the different conditions of your experiment. Your textbook goes into greater detail about the mathematical equations behind what is done behind the scenes in SPSS, so I'm not going to go into detail about that because it can get very confusing. So if you're interested in that, you can review the textbook, but I do not expect you to memorize those equations since we will be doing all of these calculations in SPSS. So we're going to link these tests to the program evaluation designs. So here's an example of a one group post-test only program evaluation design. This is, as you may recall from previous module, that this is the lowest level design. But this is an example of using this design with an independent t-test. So the example is one group of patients are administered an 8-week weight loss program and are only assessed after the program on demographics, knowledge, intentions to maintain healthy behaviors, and BMI. So they have no pre-test, they're involved in a program, and then they're measured one time after the program. So we're assessing all those variables, BMI, healthy behaviors, knowledge, demographics, just after the weight loss program. So our research question is there a statistical difference? Is there a statistical difference in the post-program mean BMI between the males and females who took part in the same weight loss program? So it's good to get into a habit of identifying your dependent variable, your independent variable, and both their levels of measurement, as well as identifying the categories for your nominal and ordinal variables. And I make you do this on your homeworks, so you will get in the habit of doing it, but even in the future, it's good to set this up before you continue doing anything. So in this case, your DV is post-program BMI, which is measured continuously, and your IV is gender. Which is measured nominally as male and female. Well, these categories are independent because you cannot be male and female at the same time in this study. So your test would then be an independent t-test. Down in the bottom where those two boxes with the males and the not equal symbol to females for BMI would be your alternative hypothesis, because your null hypothesis would be that you find that their post-program mean BMI is the same. So your alternative hypothesis is that those post-program BMIs are not the same between males and females. Your independent t-test, these are two examples of a post-test only comparison group design. And then the second just illustrates if you randomize your people into those two groups, then that would be a post-test only control group design. You're more likely to use these two designs in your practice in the future during your ALE or for your thesis. So in this example, everyone is in the weight loss program for the comparison group design. And then after your program, you want to compare them to a similar clinic with similar individuals who receive just the standard of care. They didn't receive this new weight loss program. And then you want to assess the people in your weight loss program and the people in this other standard care on the same measures near the same point in time. Some reasons you may not want to do a pretest. Maybe your program's only an hour long and you can only pretest them immediately before that hour and immediately after. This can lead to recall and have the people in your program regurgitating information, but not truly showing that their knowledge is increased. So in this case, this research question is post-weight loss program BMI statistically different between those who participated in the program and those who did not. So your DV is post-program BMI, which is measured continuously, and your IV would be program group, which is measured nominally as weight loss program versus standard care group. And those are independent categories because you can't be in both the weight loss program and the standard care since they're at two different clinics. So you're going to use an independent t-test in this situation. Here's just an overview of how to enter your data into SPSS. So each row should be a person in your study. There should be one column for the dependent variable, and there should be one column for the independent variable. And you're going to need to assign a numeric value to each independent variable group. So maybe you're going to use 1 as the program group and 2 as your comparison group. You could also use 1 and 0. Just make sure you remember which label you're using for which group. So more details on this. You use the first column of the data file to show SPSS the difference from your two conditions. Or the third, that's fine. Then you're going to use those two different numbers to represent each of your two conditions. You're going to have that column have a meaningful name. It's typically a good idea to have IV in that name, just so you remember. Then you're going to use the other column to type the data collected for each participant in each condition. So make sure that you list the people, if you're using 1 as your program group, you're listing the people in the program group as that number 1 post-BMI. Make sure you make that a meaningful name as well. Typically you can use DV in the name of that variable. It'll help you remember what it is. And finally, make sure you save your data file so that you can re-access it in the future if needed. And remember that you assign the values that you're using for these groups. So you can pick 1 and 2, 0 and 1, 10 and 50. It doesn't matter what the values are, but it's typically easier to pick just 1 and 2 or 0 and 1. So there's 6 steps when you're conducting an independent t-test. Some of these are already done for you. So writing the null and alternative hypothesis, I talked about a little bit on the independent t-test slide 3 slides ago with the green boxes. Then you'll want to choose a significance level. So in this class, it's always going to be 0.05. Once you're done here, you may choose a different level. So that's something to keep in mind, but always use 0.05 in this class. Then we'll compute the test statistic. So decide what test you'll be using. Determine the critical value. That's not as critical in this class because we're going to be using SPSS. We won't be calculating this by hand, but it is something if you were to do this by hand, you would need to be aware of. And then if you were doing it by hand again, you would reject the null hypothesis if the absolute value of the test statistic is greater than the critical value. But you'll be using the value, the p-value, to determine significance in this case. And then you'll state your conclusion professionally. There's another video on the homepage that shows how to actually perform these tests in SPSS. So I'm not going to go into detail about that here, but you can see that in SPSS. So here's just an example of kind of setting up an independent samples t-test. Does the maximum number of alcoholic drinks consumed in any one day in the past month statistically differ between male and female college students? What are the DV and IV variables? How are they measured, and what are the categories if they're nominal or ordinal? So that's an example of a question you may get on a homework assignment. So from your data that you'll see either in the assignment or in SPSS, you'll be able to identify the number of males, the number of females, and then you'll be able to calculate the means and standard deviations, which are shown on this slide. Here, then you'll write out your null hypothesis, which would be that the mean number of drinks is equal between males and females. And your alternative hypothesis is that males' mean number of drinks is not equal to females' mean number of drinks. Next, you'll set your significance level, which is 0.05, and you'll be using a two-tailed test. And we'll be using two-tailed tests from here on out the rest of the semester. And finally, you'll be using an independent t-test because you can not be a male and female at the same time. They're independent. So for number 5, you will get your SPSS output, and your test statistic will be shown as t, and this t value is 2.60, and your output may show then a result of a p-value that's less than 0.05. So you'll reject the null hypothesis and report that there is a statistical difference between your means. Number 6 is a conclusion in standard notation and kind of an example of what I'm expecting in your write-ups for this homework and future homeworks as well. So a higher mean number of drinks was reported for males. Then you report the mean and the standard deviation as compared to females. And then you report that mean and standard deviation. The t-value, in parentheses, that's the degrees of freedom. And then after the equal sign is your actual t-value. And then after the comma, you'll put your p-value. Now here it just has less than 0.05. But in your homework, I want you to indicate and report the exact p-value to 3 decimal places. And remember that a p of less than 0.05 means that there is a statistical difference, and a p-value of greater than or equal to 0.05 means there's no statistical difference. You'll also see in the SPSS output that there is a 95% confidence interval shown. So if the 95% confidence interval does not include 0, it indicates that we're 95% confident that there is a difference between the means of the two groups. In the previous example, the difference between the number of drinks for males versus females is a positive difference. Another way to state this could be we are 95% confident that the true population mean difference between males and females will be positive and fall between a 0.6 and a 4.6 drink difference. 0.6 and 4.6 are values referenced to what is in SPSS output. If the 95% confidence interval does include 0, we cannot say that we're 95% sure that there's a difference between the means of the two groups in all cases in the population. You may actually see a difference in your sample, but a different sample from the same population may not show